So this is a worksheet that we were supposed to do on day 3 of parabolas. As you can see, the entire left column, questions 1, 2, 3, 4, all have the a value of 1 or -1. The a value of 1 or -1. Now that should make it easy, because instead of using an XY table, you could use the pattern 1, 1, 2, 4, 3, 9. Okay? Because that's how that's the pattern of any parabola that has an a value of 1 or -1. So let's just walk through number 1. Step 1, whenever you find whenever you graph a parabola, step 1 is to find the vertex. Everybody write down the word vertex and also put a coordinate, because that's where we're going to write the vertex once we find it. And then how do we find it? We find it by using the formula. X equals -b over 2a is correct. Okay, so anyhow, how do we find the vertex? We use x equals -b over 2 times a. And when we use the formula, we're going to plug in with parentheses -b over 2 times a. And of course, you look at your standard form equation, the a is in front of the x squared, the b is in front of the x, and there is no x. The c is the number -3 that's all by itself on the right-hand side. So there is no b value, which means that the b value is 0. So you put a 0 inside of the parentheses. And the a value, we said, is the number in front of x squared, which is a 1. So when you do this math, -0 divided by 2, that's just x equals 0. Okay, so the vertex x value is 0. How do you find the y value once you already know the x value? Plug it in. So we're going to plug in 0. The x equals 0. We're going to plug it in right into x, because x equals 0. So you plug it right in there. And let's do the math in our head here. What's 0 squared? And what's 0 take away 3? -3. So 0, -3 is the vertex. Let's graph that vertex on the parabola. On the xy plane. 0, -3 is right here. And what's the very next step once you graph the vertex? Even before the xy table. To draw your axis of symmetry. Okay, now, I've been saying, that you just draw the vertical line going right through the vertex. And that's true. That's how you draw it on the graph. But we also need to be able to state the equation of that vertical line going right through the coordinate 0, -3. So keep this in mind, guys. The equation of the axis of symmetry is simply, and it will always be, x equals the x value of your vertex. So what's the x value of this vertex? 0. So the axis of symmetry equation is x equals 0. Okay? So on some tests, maybe on the final itself, they'll tell you what is the axis of symmetry, and you're going to have to state the equation x equals 0. Remember, x equals a number is simply a vertical line through that x value. So for example, if I had the vertex over here, then what would my axis of symmetry be through that red dot, that new red dot? That would be x equals 3. If I had my vertex over here, then the axis of symmetry would be x equals -4. So the axis of symmetry is simply the x value of your vertex. It's really simple. Okay, anyhow, we know the vertex, we know the axis of symmetry, we just need some more points, right? So you can, if you want to, go to an XY table and start plugging in some numbers. But we already know that any parabola, any quadratic equation with the a value of 1 is going to have the pattern 1, 1, 2, 4, 3, 9 from the vertex. Okay? So I want to go with the pattern. All right, let me write the pattern right here. 1, 1, 2, 4, 3, 9. So instead of using the XY table from the vertex, I want to go 1 over, 1 up and put a dot right here. And then I'll go back to the vertex and I want to go 2 over, 4 up. So from the vertex, 2 over, 1, 2, 3, 4 up and put a dot right there. And last but not least, we're going to go 3 over and 9 up. And I think I'll be off the graph. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm 1 off the graph. It's okay. If it's 1 off, I usually draw it right off the graph right there. And now, since we know that that green line that we drew, the axis of symmetry, provides the symmetry from one side to the other, In other words, it does a reflection on the other side of it. So I could just count this red dot, move it over 1 unit to the other side, and you'll get that reflection. The next one, it's 2 units over, so go 2 units, and you'll get that point right there. And the last one, which is clearly off the graph, it's 1, 2, 3 units away, 1, 2, 3 units away. Let's put a dot right here. Now, do we need to draw those dots off the graph? No, you don't. I just like doing it. So when I draw my parabola, connecting the dots that are actually on the XY plane here, I like to be able to extend it a little and then put an arrow pointing towards that last dot up there. Okay. And likewise, I want to do it to the other side. As you can see, it's pointing right to that other dot. So this is a perfect graph of this parabola, y equals x squared minus 3. Now, in addition to that, we need to know, we already stated the axis of symmetry, it's x equals 0. We already graphed it. What other things could we say? What is this a maximum or a minimum? Does it have a maximum or minimum value? Minimum value. So it didn't ask that on the instructions, but it's always good to say, oh, it's a minimum value. What is the minimum value? If they ask you what is the minimum value, just say your vertex. 0, negative 3 is the minimum value, okay? Because the vertex is your maximum or minimum value. What else could we say? Let's talk domain and range, okay? Domain and range. Domain. And I hope we remember from way back when we graphed lines and we had functions where we put in inputs and pulled out outputs. What were those numbers that we were plugging in? Those were called the inputs, that were called the x values, and they're also called the domain values. You guys remember that? I hope. So the domain are simply your x values of the graph that you have, okay? And the range are simply the y values of the graph that you have, okay? So let me ask you this. We could look at this visually or we could look at it numerically. Bless you. We know that here's a vertex, and we know it goes up this way. Does it ever go perfectly straight up? No, right? I mean, if I wanted the next coordinate over, which is up here, you plug in 3, and you do the math, and you get that coordinate up there. Could I plug in could I plug in a 5? Yeah, I could plug in a 5. 5 squared is 25. Bless you again. 25 minus 3 is 22. So when I go out to 5 for the input, I'll get a 22 for the output, which is off the graph. But my point is, it really does continue that way forever, and it really does continue this way forever. Because you could plug in any x value you want. You could plug in the x value of 5, which is right here. You could plug in the x value of 7, it'll be way up there. You could plug in the x value of 10, you could plug in the x value of 100. You could also plug in the x value of negative 5 or negative 10 or negative 1,000, whatever you want. You could plug in any x value you want. So when it comes to the domain, when it comes to the x values, what do we say the domain of this graph is? We say x equals all real numbers. That's the domain. X equals all real numbers. Now let's talk about the range. Well, first of all, do we understand that the domain is x equals all real numbers? What does that mean? It means that your x value could be any number you want. And that makes total sense visually because it does go this way forever, and it also makes sense numerically. Like I said, you could plug in, remember the domain are your inputs, your x values. You could plug in any number you want. You could plug in a fraction if you want. You could plug in a decimal. You could plug in 1,000. You could plug in negative 1,000. You could plug in any number you want. So the domain, your x numbers, you could plug in any number you want. How about the y values, the range values? Now, if you look at this parabola, we know that it has a minimum value, okay? So like, what's the height up here on the parabola? The height is 6, right? What is the height right here? What's the height of it? The y value of it? Anybody? What's the height? 1. What's the height right here? 0. What's the y value right here? Negative 1. What's the y value right here? Negative 2. What's the y value here? Negative 3. Does it ever go below negative 3? No. So it has a minimum value with regards to the y's at negative 3. So if I'm asking you for the range, I'm asking you for all the possible y values of this U-shaped curve that goes up forever. So we know that it never goes, now, you don't have to draw this, all right? I'm just drawing it so you could see it. The whole parabola is above this blue line. It's not below that blue line, right? So what do we say the range is with regards to the y values? Right here, your y value is -3, and we know that this whole parabola is above -3. So what do we say the range is? We say y is greater than or equal to -3. It can't be -4, it can't be -5, it simply does not exist down here. So this whole parabola is the lowest point is -3 on the y's. The whole parabola is above -3. So the domain and range is analyzing your graph once you finished it to determine where your graph is at. Now, of course, with the x's, it's always going to be, with your domain, it's always going to be x equals all real numbers. Because every single parabola, it doesn't matter if your parabola is wide or if it's really narrow, your parabola is still going to go to the left and to the right forever. You could still plug in any x value you want. But the range is the only tricky part. Okay, so if you understand this, guys, the domain of any parabola is what? X equals all real numbers. Remember that? You get half credit already when it comes to domain and range. You'll know half of it. Okay, so the domain of any parabola is x equals all real numbers. Okay? The range is the y's, the up and down part. That's where it gets a little more challenging. Where's this graph at? It's above that certain y value. What is that certain y value? It's -3. Now, it might be, the parabola might be going down, and then you have your range below a certain value. Let's do number 2 right here. Start with what? What's the first step? I'm going to go through this one faster. Vertex. And of course, do the coordinate, and of course, write down your formula. And replace with the letters with parentheses. And then plug in your values that you identify. The a value is -1, the b value is -2, the c value is 1. So we're going to be plugging in a -2 inside of the parentheses over a -1. And when we simplify this, a negative becomes positive, and 2 times -1 is -2. So I really have +2 up on top over -2 on the bottom, which means that my x value really is -1. So that's the vertex x value of -1. How do I find the y value once I already have the x value? Plug it back in. So what I'm going to do now is I'm going to rewrite this entire equation right here on the side, but I'm going to put parentheses in place of these x's because I need to plug them into those parentheses. So there's my equation with parentheses. I'm going to plug in the x value of -1, put a -1 right in there and a -1 right in there, and then we do the math. We always start with parentheses, but there's nothing to do inside of the parentheses. So we go to exponents, -1 squared, that's just 1. Don't forget about the negative sign that's in front. And don't forget about the rest, the -2 also times -1 and then +1. So let me do the math, and after exponents we multiply right here. So -2 times -1, that's +2. So let me rewrite the whole thing. I have a -1 in the front. Right here I got a +2 and I also have a +1. So what's my actual y value going to be? What's -1 plus 2 plus 1?
2.
Thank you, 2. So our y value of our vertex is 2. Let's graph that vertex of -1, 2. That's right here, -1, 2. What's the next step after plotting your vertex? What do you do next after plotting the vertex? Axis of symmetry. Some teachers don't make you draw it. I like seeing the drawing, like a dotted line right there. And then after that, you want to go to an XY table. Now, remember, if it were any other graph, you could plug in any 2 numbers that are on the same side of this axis of symmetry. So you might want to plug in 0 and 1. Now, I'm just going to do it here. I'm going to leave it like that. Because instead of doing this work, because the a value is -1, we could use the pattern 1, 1, 2, 4, 3, 9. That was the pattern that we got off the parent graph. So since we know that it opens up or down, does it open up or down? Down. Why? Because it's negative, right? So I know it's going to open down. So I'm going to use this pattern, but knowing that it's going to open down. So from this point, I'm going to go 1 over, 1 down. And I'm going to put a dot right here. Okay? And then I go back to the vertex. And then I do the next one. 2 over, 4 down. 1, 2, 1, 2, 3, 4. And put a dot right here. and we go back to the vertex and go 3, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to do it. It's off the graph, all right? But anyways, let's reflect them over to the other side. You get a dot right here, and you get a dot over here, and you have yourself a pretty good parabola. Now, if I had a 10 by 10 graph, I would have plotted the 3, 9 pattern. But since it's off the graph right here, more than one unit, I'm not even going to draw it. That's my parabola. How about it? Max or min? Max. Right? This is like in the path of throwing a ball. You throw a ball up in the air, it reaches a max height, then it comes back down. Okay, so we know for a fact that it's max. If I did ask you, what is that max height value? What would you say?
2.
You would say 2. Or you could also state the entire vertex. -1, 2 is the maximum height. But yeah, the max height in regards to the y's is 2. Okay, so now let's talk about, how about what is the equation of the axis of symmetry? X equals, what's the equation? No. I'm not talking domain. I'm talking about the equation of the vertical line, that green line that crosses right through the vertex at -1, 2. What's the equation of that axis of symmetry? Remember, any vertical line is, the equation looks like x equals a number. So what's the equation of this green line that crosses through the vertex -1, 2? X equals -1, guys. Okay, now what if I told you graph the equation x equals 3? Oh, that would be a vertical line right there. What if I told you graph the equation x equals 5? Oh, that would be a vertical line right there. So if I'm asking you for the equation of the line that crosses through the vertex, and that would simply be x equals the x value of the vertex. Keep that in mind, guys. The axis of symmetry equation is simply x equals the x value of the vertex. So whatever answer you got here using the formula, that's going to be the equation of the axis of symmetry. Now let's go to what you guys were thinking about, the domain and range. So the domain, and you can't just say all real numbers, you have to say x equals all real numbers, right? Remember, the x values, here's your x-axis, it's left and right, and we know that this parabola, even though it goes down, it never goes straight down, it keeps going out. It keeps going out to the sides, right? So it really does go to the left forever and to the right forever. Now the hard part. The hard part is the range. The range, y is what? Y is, now remember, y's are up or down. Now the parabola is at a certain value and below it, right? This parabola is right here at this value. Remember, this is your max value. Is it at -2? No, the max value of this is right here at the y value of 2, right? So you want to describe that this entire parabola is below this y value of 2. So how do we say that the entire parabola is below the y value of 2? Y is less than or equal to 2. Okay? So this is the very first time I'm actually asking you to jot down your domain and range. Remember, the domain of any parabola will be x equals all real numbers. The range is simply going to be either above or below a certain value. I mean, we looked at this one up here. This one up here was above the y value of -3, and it actually touches. That's why it says y is greater than or equal to. And same thing down here. This entire parabola is below the y value of 2, but it does touch it. That's why it's y is less than or equal to 2. Okay, so it took me 20 minutes to describe these first two questions. Now, question 3 and 4 are almost identical to 1 and 2. So I'm going to end this video right here and have you guys do 3 and 4.